Chapter 9, Section 5, Trigonometric Ratios. The trigonometric ratios are going to be sine, cosine, and tangent. If you'll notice, sine is abbreviated SIN, cosine is abbreviated COS, and then tangent is abbreviated TAN. Notice to the right side of your screen you have a triangle, and I've gone ahead and I've labeled angle A. Trigonometric ratios only work for the acute angles of a right triangle. So for angle A, I've marked the side opposite of angle A, we're going to call opposite. The hypotenuse of the triangle is going to stay called the hypotenuse. And then the leg that's forming angle A is going to be called adjacent. I could talk about the other acute angle of this triangle, but when I did that, my opposite would then be the bottom side, and my adjacent would then be this, the vertical line. So depending on which angle you're talking about is going to depend on which side is opposite and which side is adjacent, but it's the relationship to the acute angle that you are using to find sine, cosine, and tangent. What sine is, notice I have sine of A equals. A is going to be referring to the angle. So the sine of angle A and the sine of any acute angle of a triangle is going to be the length of the side opposite over the length of the hypotenuse. The cosine is going to be the length of the side that is adjacent over the length of the hypotenuse. And then the tangent is going to be the length of the side opposite over the length of the side adjacent. One way that people remember sine, cosine, and tangent, and the ratio of sine is opposite over hypotenuse, adjacent, cosine is adjacent over hypotenuse, and so on, is the acronym SOHCAHTOA, or SOHCAHTOA. It's spelled SOH, which would refer to sine is opposite over hypotenuse. And then it would be CAH, which would mean cosine is adjacent over hypotenuse. And then TOA, which would mean tangent, is going to be opposite over adjacent. There are several little tricks to help you remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Sometimes you can think about alphabetical order, and that can help. But there are... like I said, there's several different ways. You can come up with your own way, but you do need to remember these trig ratios. You do need to remember that sine would be the length of the side opposite over the length of the hypotenuse, and so on. So you will need to memorize this information. This first example asks us to compare the sine, cosine, and tangent of the ratios for angle A in each triangle below. Sine of A for the first triangle, notice with the side lengths of 5, 12, and 13, the sine of angle A, or the side opposite angle A, would be 5, and the hypotenuse of the triangle is 13. So for sine of angle A, we would have 5 over 13, and I'm going to go ahead and divide those and come up with a decimal. So 5 over 13 is the same as 0.385. For cosine, it would be adjacent over hypotenuse. In this case, it would be 12 over 13, which is 0.923. And then for tangent of angle A, which would be opposite over adjacent, I would have 5 over 12, which is decimal 417. They also want me to find the sine, cosine, and tangent of A in the second triangle. In this case, I have side lengths of 2.5, 6, and 6.5. The sine is opposite over hypotenuse, so for this triangle it would be 2.5 over 6.5, which is 0.385. Cosine of A would be adjacent over hypotenuse. In this case it would be 6 over 6.5. When we divide that, we get decimal 923. And then for tangent of A, it would be opposite over adjacent, which would be 2.5 over 6, which is 0.417. If you notice here, the sine of A in both triangles is the same. I get 0.385. The cosine of both angles A in both triangles is 0.923, and then the tangents are also the same. If you look at these two triangles, you hopefully can tell that these would be similar triangles. All of the sides are proportional, and we've just spent a lot of time talking about similar triangles. So hopefully you can realize that these are proportional triangles. Remember that in similar triangles, your angle measures are congruent, which means that angle A in the first triangle is going to have the same measure as angle A in my second triangle. This is important. Each angle measure that is 89 degrees or less, so each acute angle measure is going to have a certain sine, cosine, and tangent. They're going to be the same for whatever, regardless of what triangle they're in, for that measure. So, if you have like the sine of 30 degrees is always going to be the same in any triangle, that proportion of opposite over hypotenuse will always give you the same decimal. In this case, it was 0.385. I'm not sure what the angle measure here is. We're not to that point yet. But we know based on the sine, cosine, and tangent and the fact that these are similar triangles that angle A is going to be congruent in both of these angles, or both of these triangles. The next example says find the sine, the cosine, and the tangent of the indicated angle. For A, they want us to find for angle D, and then for B, they want us to find for angle E. If you look at this example, first we're going to look at angle D. So notice angle D would be in the bottom right-hand corner of this triangle. For sine, the side opposite of angle D would be 14, and the hypotenuse is 50, so I would have 14 over 50, which is 0.28. For cosine, the side adjacent would be 48 over the hypotenuse, which is 50. So 48 divided by 50 is 0.96. And then for tangent, I need to do opposite over adjacent. The side opposite is 14. The side adjacent is 48. So I would have 14 over 48, which is 0.292. Now I want to look at sine, cosine, and tangent for E. Notice D and E are my two acute angles of this triangle. When I look at sine of E, now that I'm talking about my angle E, the opposite now is 48, but the hypotenuse is still 50. So now my sine of angle E would be opposite, which is 48 over 50, which is 0.96. The cosine for E, now the side adjacent would be 14. The hypotenuse is still 50, so 14 over 50, which is 0.28. And then the tangent for E is opposite over adjacent, which would be, in this case, 48 over 15, which is 3.429. So far, I think in our examples, I'm not sure if we've had an answer over 1. But as you can tell by the tangent of E, some angle measures for the different trig ratios, their answer is going to be greater than 1. In this case, it's almost 3.5. So you don't have the wrong answer if you get what you think is a number that's too large. If you take a second and look at these, notice that the sine of D and the cosine of angle E are the same, and then the sine of E and the cosine of D are the same. And that's going to be true for all triangles. If you think about it, notice when we went from talking about angle D to angle E, the side we are considering opposite and the side that we're considering as adjacent is going to be flip-flopped. And if you look at the tangent of D and the tangent of E, notice that those have just been the reciprocal of each other. So we've just flipped 14 over 48 to 48 over 15. That's going to be true anytime you're talking about one triangle and the sine, cosine, and tangent of their two acute angles. This next example says find the sine, the cosine, and the tangent of angle A. In this case, angle A is again in the bottom right-hand corner of this triangle. The side opposite of angle A would be 18, and this side that is adjacent is 18 square roots of 2. This could be simplified to 1 over the square root of 2, which is 0.7071. You didn't have to necessarily simplify it. You could plug this into your calculator and it would work out just fine. One little piece of advice on calculators is to make sure that you're using your parentheses. If you were going to plug this into a calculator, the 18 divided by 18 square roots of 2, you want to make sure that you put parentheses over what's in the denominator because we actually want to multiply 18 times the square root of 2 before we divide it by 18. So just a little side note, be careful on your calculators how you're plugging things in. The cosine of A is going to be adjacent over hypotenuse. In this case, because I do have an isosceles right triangle, my adjacent side is still going to be 18, but this time I'm talking about the 18 that comes from the segment CA or line CA. So in this case, I'm going to have 18 over 18 square roots of 2 again, which will give me 1 square root of 2, which is 0.7071. This actually makes sense, sine and cosine, to be the same here because we're talking about a 45-degree angle. And then the tangent of A would be 18 over 18, adjacent over opposite over adjacent, which is going to just be 1. I would encourage you to go ahead and pause this video, or you can keep going. Just make sure that you take the time to actually plug this into your calculator. So it asks us to approximate the sine, cosine, and tangent of 82 degrees. If you plug it into your calculator, and one thing before I, just to make this note, if you're in my class, then you've heard me say it several times already. When we are, for geometry, and my geometry class at least, we're only going to be talking about angles in terms of degrees. When you are using a calculator, you need to make sure that you have it, the mode is in degrees. There should be, on any calculator that you use, there should be some way. Sometimes it's a scientific button, sometimes it's a mode button, but there should be some way to get in to see what mode you're in. So the other things that you could see would be RAD or GRA, I believe. But you want to make sure that we're in degrees, which means on your screen somewhere you should see a little, it'll just be a little tiny something in a corner usually, and it should say DEG. If you don't see DEG for degrees, that means you're probably in either radians or gradians, and which means that you need to go in and change your mode to degrees. So if you don't get the right answer, that means that your calculator is probably not in the right mode. So if you plugged in sine of 82 degrees, you should get 0.9903. If you plug in cosine of 82, you should get 1.392. And then if you plug in tangent of 82, you should get 7.1154. To use the trigonometric ratios, if you know an acute angle of a right triangle and one side, you can use the trigonometric ratios to find the length of the other sides. This example says you're measuring the height of a building. You stand 100 feet from the base of the building. You measure the angle of elevation from the point on the ground to the point on top of the building to be 48 degrees. Estimate the height of the building. I'm going to go ahead and draw a picture. I know that I'm 100 feet away from the building. I know that my angle of elevation is 48 degrees, and I want to find the height of the building, which I've already marked as X in this triangle. Notice this would be a right triangle. I know an angle measure, which is 48 degrees. And then I also know the side, or I want to find the side opposite. And I know the side adjacent. Because we know the side adjacent to the 48-degree angle, and we want to know the side length opposite the 48-degree angle, we want to use would it be sine, cosine, or tangent? Which one uses opposite and adjacent? In this case, it would be tangent. How we're going to use this is we're going to say the tangent of 48 degrees equals the opposite, which is X, that's what I'm trying to find, times the adjacent, which is 100. My goal is to solve for X, and what I need to do to solve for X on both sides would be multiply both sides by 100. When you multiply both sides by 100, you get 100 times the tangent of 48 equals X. You're going to use your calculator and you can plug it in. 100 times the tangent of 48 degrees is about 111 feet. So to answer this question, my building would be about 111 feet tall. This next example says a driveway rises 12 feet over a distance d at an angle of 3.5 degrees. Estimate the length of the driveway. I'm going to go ahead and I'm going to draw myself another picture. It tells me that it rises 12 feet, so I've labeled the height of this triangle 12, and it tells me over a distance d. So my base is going to be d. They tell me that I have a 3.5 degree elevation, and they want me to estimate the length of the driveway, which in this case would be x, the hypotenuse. If you examine this triangle, because we know the side opposite, the 3.5 degree angle, which is 12, you want to know the hypotenuse, what uses opposite and hypotenuse, which trig function uses opposite and hypotenuse, and the answer would be sine. The way that I need to set this up would be to have sine of 3.5 degrees equals 12 divided by x. These get a little bit more complicated than the other one. I want to solve for x, but I need x to be in the numerator. So what I'm going to do is I'm actually going to multiply both sides by x, which would give me x sine of 3.5 equals 12. Then to get x by itself, I would need to divide both sides by sine of 3.5. So I'm going to end up with x equals 12 divided by sine of 3.5. Go ahead and plug this into your calculator. Make sure that you close up all the parentheses that you use, and you should get about 197 feet for x. Today's assignment is on page 562. It's numbers 10 through 42 even, numbers 53 and 54.